I've been asked to speak at a number of medical conventions all over the world. Cuba invited me to keynote a medical conference for doctors from Latin America and Europe. Mexico City had me talk to anti-aging doctors, and then another one was in Las Vegas. And what they don't know, we'll see if you knew. There'd be no oxygen transfer without glutathione. You would take this nice deep breath, but the oxygen wouldn't go anywhere, just in your lungs. It wouldn't go to the cells in your body. Your cells would die very quickly, then the tissues, then the muscles, the organs, and you're dead in a matter of minutes. Because when hemoglobin, the red blood cell, is manufactured, the whole purpose is to bind to oxygen, but it can't. It has the wrong electrical charge. It's like trying to bring north poles of magnets together. You think you can touch them together, but man, the closer you get, then this vibration starts and you can't touch it. Same thing with hemoglobin and oxygen. The hemoglobin has to be reduced to a positive 2 charge, and the only thing that can make that reduction, the sole reduction agent of hemoglobin, is glutathione. So no oxygen transfer without it. Let's see, here's my thing. Here we go. Immune response. We've all been through the pandemic. We know how important our immune system is. Our immune system is designed to protect us from viral and bacterial insults. And the way it works is whenever you are attacked by a virus or a bacteria, your immune system goes into overdrive and starts thinking, okay, how are we going to beat this thing? And as it figures it out, it sends out the assassins, 2 assassins to kill the bacteria or virus. Not 1,000, but 2 different assassins. The T cells and the B cells. How fast they reproduce in response to a bacterial or viral insult is entirely dependent on your glutathione level. If you have low glutathione levels, they reproduce sluggishly, while the bacteria or virus is reproducing rapidly. Guess who wins? The virus, the bacteria. You lose. You get sick, maybe you'll die. All because of that slow reproduction process. Glutathione speeds it up. Now, glutathione is the detoxifier of the cell. Every cell in your body uses glutathione to get the chemical loads out of the cell. Everybody in here has at least 200 chemicals in your body, at least. They're not supposed to be there. Glutathione, that little yellow part of the molecule, is a sticky sulfhydryl molecule that's like flypaper, or those spider traps that are so sticky, you can buy them anywhere. And it sticks to the chemical, and it gets it out of the cell. That's how it protects the mitochondrial DNA. You see, it's the chemical load inside the cell that breaks the DNA. And when it breaks that DNA, the cell can mutate. Well, we protect that by raising glutathione, which lowers the chemical load in the cell, and then it protects the mitochondrial DNA for longer. Do you know, everybody, how many people here don't use a cell phone? Raise your hand. How about a computer? How many of you don't use a computer? Okay, well, you're being subjected right now to a form of radiation that comes from those cell towers, and it's EMF. And 5G, which is taking over the United States, I don't know about here in the Philippines, actually creates a bad reaction inside the human body. It causes the human body to produce a new free radical. I'm going to tell you about free radicals in a second, but that free radical is vicious. It lives 1 billion times longer than any other free radical. It attacks your DNA. Uh-oh. It's called peroxynitrite. Guess what the one and only antioxidant that can take it out? Glutathione. You got it. You're learning. Okay, so let's talk. So we lower the chemical load. It also chelates heavy metals. We all have heavy metals from what we eat, what we drink, what we breathe, things like mercury, arsenic, cadmium, copper, and so on. And glutathione is the primary chelator of heavy metals. Okay, now we're going to talk about, does this work? Can we turn that on? Okay, we're going to use this. Okay, I got to think. Okay, so let's talk about, how many of you have heard of antioxidants? Raise your hand. Okay, I'm going to tell you things about antioxidants that even people that are in anti-aging medicine don't know. An antioxidant, well, basically they're meant to mitigate free radicals. A free radical is a scavenger. It's a thief. How many of you have ever had anything stolen? Raise your hand. Don't you feel violated if somebody steals, even if it's something insignificant? You come home or get back in your car and it's gone, and you feel like that's not right. You feel victimized. Okay. How about something that's going to steal your life, your health? And that's what free radicals do. They're looking for, they want to steal an electron from your cell. And when they do, some terrible things happen. Number one, it creates oxidative stress in the cell. That oxidative stress does two terrible things. It creates inflammation, and it accelerates the aging or death of the cell. That's what oxidative stress does. Now, antioxidants work by donating one of their electrons to the free radical, and when they make that donation, it sequesters or captures that free radical, and it makes it so it can't hurt you. Problem is, there is a host of free radicals, so I'll do this. Here we go. I know that looks goofy, but all of these are different types of free radicals. Oxygen-based, nitrogen-based, hydrogen-based, different structures, different compositions. And every antioxidant, vitamin C, vitamin E, vitamin D, vitamin A, CoQ10, superoxide dismutase, catalase, they all are monofocused. Each one can take out one type of free radical, but they can't take out any of the others. So they're like that hotel key that I have in my pocket, one of these pockets, I hope. Here it is. This hotel key